Good morning, students. I am Professor Priya Sharma of EC Department, SIRT College, Bhopal. Sejanandam. So this is our fifth lecture of our lecture series, which we are continuing of the subject digital circuit systems. So fifth lecture is on multiplexers and demultiplexers. So basically, first of all, what is a multiplexer? So a multiplexer is also known as a data selector. A multiplexer is a device that allows the digital information from the several sources to be routed onto a single line for the transmission over that line to a common destination. Basically, the multiplexer is known as data selector as it selects the data from a single input line and from multiple input lines, and only one data is selected and it is being transmitted through the outline. So there are several data input lines, some selection lines, and a single output line. If there are n data input lines and m selection lines, then it is being written as 2 to the power m is equals to n. This is the functional diagram of a multiplexer where there are multiple input lines, as you can see, input lines and some selection lines, and there is a single output line. So basically, depending on the combinations of the selected lines, the input is being connected to the output line. As we have seen that 2 to the power m is equal to n. So the multiplexer will have the inputs raised to the power of 2's. 2 to the power 0 is 2, 2 to the power 2 is 4. So we'll get 2 is to 1 multiplexer, 4 is to 1, 8 is to 1, 16 is to 1, and so on. So 2 is to 1 multiplexer will have two input lines, one selection lines, and output line will always be 1. The truth table for 2 is to 1 multiplexer can be written as when the selection line is 0, I0 will be connected to the output, and when the selection line is connected to 1 or high, I1 is connected to as the output. For 4 is to 1 multiplexer, the truth table is given here. We have 4 is to 1 multiplexer, we have 4 inputs, 2 selection lines, and usually 1 output. For 4 is to 1 multiplexer, we'll have the possible combinations of 0, 0, 0, 1, 1, 0, and 1, 1. So when S0 and S1 both are 0, then I0 will be connected as an input to the output. For 0, 1 selection line combination, I1 will be connected to the output. For 1, 0, I2 is connected to the output, and when both the inputs are high of the selection lines, I3 will be treated as the point of connection for the output. For 8 is to 1 multiplexer, there will be 8 inputs, 3 selection lines, and 1 output. This is the proper logic diagram of the 8 is to 1 multiplexer. Now coming to the multiplexer tree. So what is a multiplexer tree? The multiplexers with more number of inputs can be obtained by cascading two or more multiplexers with less number of inputs. Let me explain this with the help of an example. This diagram is of 16 cross 1 marks, in which we are using 4 is to, sorry, not 4, it's actually 4 is to 1 multiplexers. So you can see here from x0 to x15, there are 16 inputs and only one output. The selection lines are only 2 and 2 here and 2 here. So total for 16 is to 1 multiplexer, we require 16 inputs, 4 selection lines, and 1 output. So these 16 inputs are divided into a pair of 4 inputs by using 4 is to 1 multiplexers, and the selection lines are divided into 2 here and 2 here. So these two selection lines are made common for all these 4 multiplexers, 4 is to 1 multiplexers, and the rest of the 2 selection lines are used in the for combining all these 4 multiplexers. So how it will work? You can easily go through these 4 is to 1 multiplexers as I have explained earlier. Like when S0, S1 are 0, 0, this X0 will be given, will be the output of this. When 0, 1, then X1 will be the output, and same here. After these X1, X5, X9, and X13, these inputs are given, these are given as inputs to this multiplexer 4 is to 1, and as depending on the positional values of S2 and S3, whether they are low or high, final output we will get. So this is how multiplexer tree is being drawn. Now coming to the demultiplexer. Demultiplexer is exactly the reverse functioning of the multiplexers. It takes data from one line and distributes them to a given number of output lines. For this reason, the demultiplexer is also known as a data distributor, as it takes the input from one input line and distributes it to many distributors. It has single data input lines, some selection lines, and several output lines. Again, if there are n data input lines and n selection lines, then it is can be written as 2 to the power m is equals to n. Likewise, we have seen the functional diagram of a multiplexer. The functional diagram of a demultiplexer is same. There is one data input and it is being distributed to all the data inputs, which are all the data outputs, and we have the selection lines. As we have 2 cross 1 marks, 4 cross 1, 8 cross 1 marks, similarly we have 1 cross 2, 1 cross 4 and 1 cross 8 and so on demultiplexers. For 1:2 demultiplexer, there will be one input, that is D in, one selection line, one enable line and two outputs. As 1:2, these are the number of outputs, these are the number of inputs. So when S0 is 0, the Y0 will be D. When S1 is 1, the Y1 will be equal to the data input. For 1:4 multiplexer, there will be one input and four outputs and two selection lines. So for the possible combinations of two selection lines, the outputs are taken as for 0:0, the output will be available only at D0. For 0:1, output will be available at D1. For 1:0, output will be available at D2. And for 1:1, output will be available at D3. This is 1:8 multiplexer, and this is the truth table of the same as explained earlier. This is the demultiplexer tree where one input is given and 8 outputs are taken using 7 1:2 demultiplexers. Now, questions can be asked in the exams of implementing the logic functions using the multiplexer. So, let me explain these, how they can be solved. Suppose if we are given a function f of ABC is a bar b bar c plus ab. So, in this, what we are going to do, we'll take a and b as a selection line and c as an input. Okay. So, this is the basic. If we are taking a, b and c, all are selection lines. So, how can we expect the output, that output will be high or low, and what the case is? Writing the A, B, C and all the possible 8 combinations over here from 0:00 to 1:11, we can see for A bar, B bar, C. A bar, B bar means 0, 0 and 1. For 0:01 input, we are getting the output. So 0:01 input, we are getting the output as 1. And then AB. As C is not here, so we'll take both the inputs of C, that is 0 and 1. So A and B, that is A and B is equal to 1 and 1. So 1 and 1 is over here only when both the inputs are 1. And irrespective of the condition of the C, whether it is 0 and 1, we are taking the output. As C is not mentioned here, that means after solving through K map, C has been cancelled out. That's why we have taken 1 in both the cases. In all the rest of the cases, we have taken the output as 0. So this is our final output, and we'll implement these 8 inputs over here. We have taken ABC as selection lines. We have drawn a 8 cross 1 marks. How we could know that it is 8 cross 1 marks, as there are 3 selection lines. So 2 to the power 3 means 8. That means 8 inputs and 1 output. So we'll write over here, the F will be 0, 1, 0, 0, 0 and 1. We have written in the same sequence. So this is how we can implement. Now sometimes it is being asked that use only 2 selection lines and use one of the variable as an input. So in the next case, I have used the same. The question is the same, and here I have used the selection lines A and B, and C is taken as an input. So how we can solve this? This is the output which we have drawn in the last example. So how can we implement this output using C input? Sorry, it was mistaken. Here it should be A, not C. Here it should be A. Here it is B. It is correct. So if we look at the inputs of C and outputs, we could draw a conclusion that when C is 0, 1, the output is 0, 1. That means the multiplexer is following C. When C is 0, 1, output is 0, 0. That means it is 0. When C is 0, 1, output is again 0, 0. That means it is again 0. When C is 0, 1 and the output, then the output is 1, 1. That means we have to connect it to 1. So this is how we can implement any function using two selection lines and one as an input. So C, 0, 0, 1 are the inputs. This is how it has been implemented using 4:1 marks. Earlier we had implemented it using 8:1 marks. Same function has been implemented using 4:1 marks. How it is implemented? By uh, connecting one of the inputs, one of the selection line, by using one of the selection line as an input. So C001 is an input, A and B are the selection lines, and output is the function. This is one more question which is taken as it is A, B, C, D, 4 variables. So we have to use 16 cross 1 marks. But here it is written you have to use 8:1 multiplexer. So we have to take any one of the selection line as an input. So A, B, C we have connected as selection line, and D we have taken as an input. Again, A bar, B bar, C bar, D. A bar, B bar, C bar, D. That means 0, 0, 0, 1 is taken as 1. Then A bar, B bar, C. That is 0, 0, 1, 1. 0, 0, 1, 1. This is taken should be 1. A bar, B. 0, 1, 0, 1. 0, 1, 0, 1. This is to be taken as 1. 0, 1, 0. Sorry, 0, 1, 0, 0. Yes. 0, 1, 0, 0. This should be taken as 1. Then this is 0. No, sorry. 1, 0, 1, 1. 1, 0, 1, 1. This is should be taken as 1. Then 1, 1, 0, 0. 1, 1, 0, 0. This should be taken as 1. 1, 1, 0, 1. 1, 1, 0, 1. This is should be taken as 1. 1, 1, 1, 0. 1, 1, 1, 0. This should be taken as 1. And 1, 1, 1, 1, 1. This should be taken as 1. As we have to use D as a selection line, so we'll follow the output. When D is 0, 1, output is 0, 1, that means it is following D. When D is 0, 1, output is again 0, 1, that means again it is following D. When D is 0, 1, output is 1, 0. It is inverse of D, that is D bar. When D is 0, 1, it is 0, 0, again 0. When D is 0, 1, it is 0, 0, again 0. When D is 0, 1, it is 0, 1, it is following D. When D is 0, 1, output is 1, that means 1. When D is 0 or 1, output is again 1, that is 1. So we'll implement these. We'll connect first and second input with the D. We have connected 0 and 1 with the D. On the second pin we have to connect D bar, so we have connected D bar. On third and fourth we have to connect it 0, so third and fourth pin has been connected to 0. For the fifth pin we have to connect it to the D, again we have connected this to D, and for sixth and seventh this have to be connected to 1, so we have connected these two is 1. So that's how we can solve these questions also. These are asked in parallel part of the questions, or sometimes in attachment of these questions that explain multiplexer and also solve this question using reduced form of multiplexer. So this is how we can solve. I hope it is all clear for you. In case of any query, you can ask me. Thank you. Work hard. All the best, and Sej Anandam.